Congratulations on finishing up the first test for our Calculus BC course. I'm sure you did great. We are going to go ahead and be starting our next unit tonight and into the next couple of weeks. And what we're going to be really exploring is in Chapter 3 and 4, and I'm going to pull in a little bit of Chapter 10 as well. But mainly in Chapters 3 and 4, we're looking at focusing on this instantaneous rate of change. We've really said everything we can about average rate of change, which is the slope of the secant. And we've talked some about instantaneous rate of change, which is slope of the tangent, slope of the curve, and then the mystery name. Excuse me. Now, what we're going to be focusing on here is now we can use the mystery name, which is a derivative. And this really means exactly what we've been doing the last few days in class, which is it is instantaneous rate of change, it is the slope of the tangent, it is the slope of the curve. It just is its own special name to stand for all of these. So it is a synonym with what we've been doing. And honestly, I don't really have a whole lot to add to it. We found the slope of the tangent and formalized it last week. Remember, we did it by saying if I have 2 points and I find the slope between them, and then do the limit as the distance between the points goes to 0. This is kind of the simplified version. Well, we also dealt with some situations where we didn't know what the point of tangency was, and so we just used a. Well, instead of a, we could have just left it as x, in which case this is the formal way definition for a derivative. And just because you're going to hear this, these, when it's written either of this way, this is called the difference quotient. It's just standing for finding that slope between 2 points and then moving the points closer together. If the derivative exists at a point, in other words, if the slope of tangent exists, we say that the function is differentiable at that point. If the derivative exists for the entire domain, we say the function is a differentiable function. And then if the derivative does not exist, we say it's non-differentiable. In terms of notation, this is in your book in section 3.1. I would look over this. Either pause the video to look over it or open up your book to section 3.1 to look over this table, because there are a lot of different ways we can write the notation for a derivative or slope of the secant or slope of the curve or instantaneous rate of change. These first two ways are from Newton. Well, they're a variation of it. He actually used a dot and called it fluxion with a F-L-U-X-I-O-N. But the dot kind of metamorphosed into an apostrophe. And when we see this, it is pronounced prime. So this would be F prime or F prime of x. This would be Y prime. Advantages to this, and especially initially, this is a very popular notation, is it's quick to write, it's quick to say. Disadvantage is it doesn't tell us the independent variable, which will come in handy in the second semester when we start doing these backwards. We need to know what the independent variable is. What ways that stress the independent variable are these last three, and these are from Leibniz, who is the one who gave us the name derivative. We do not say dy over dx, we just say dy dx, or df dx, or df of x dx. I don't know why we don't say over, we just ignore the fraction bar part. It is longer to say, it is longer to write. However, huge advantage in that it is telling us what we're doing our derivative of the function y with respect to x. So it tells us our independent variable. I don't really have any examples to go through because the examples are exactly like when we did examples at the end of the last unit where we did not know the point of tangency.